Hello guys, good evening. How are you all? Good evening, Vijay. Good evening, Parshurama, Ashish, Mamata, Vinay, Yashwant, Mani, Hrutik, Krishnan, Rahul, Samruddhi, Hari, Gautam, Sandeep, Renu, Sushma, Anurup, Sindhu, Samruddhi, Vijay, Jat, Suma, Maya, Guru Prasad, Vasu, Gautam, Guru, Manoj, everybody. Good evening. Good evening, Deepak, Mahata, Akhilesh, Kutu, Kamal, Deepak, Thanmay, everybody, good evening. Very good evening. I'm good. How are you all? Suman, Joshi, Bapan, Rajakumar, Soumi, Vijay Kumar, Ashish, Ganesh, Devajit, Manisha, Deepak, Sairam, Srikiran, Samruddhi, Anupama, Preeti, everybody, good evening. So let's start the session of this today's marathon session. Okay, people are joining. Let's wait for them. Again, reminding all students, a very good evening. Very good evening. So let's start. Just wait for 1 2 minutes. We can start. So hello guys, I am Bhimashankar Mantina. I did my MTech from IIT Kharagpur. I have around 10 years of teaching experience in GATE and ESE throughout the country. So with the subjects of digital circuits, microprocessors, network analysis, and the computer organization, uh, I have dedicated around 9 plus years for these two subjects only, the networks and digital circuits. So I have made the problems in all different possibles where the students can commit the mistakes. So, and also I try to solve the questions in all possible different ways so that instead of the routine regular way, the different ways you will be knowing to learn or to do the problem. Namaste. Yes, everybody just give a one like to mark your attendance. So today is Saturday. You people are enjoying the weekend. You are in the weekend mode, I think. So this is our Kreatryx team. This is the total team of us for your GATE, EC, EE and ESC also, instrumentation also. We are the best team right now. You ask any single student who is attending our classes, he will give you the feedback. We are giving you the best possible content for EC, EE. Right? So this is about me and this is my code. What is this code, sir? If you want to take the Unacademy Plus subscription, why I am saying if you want, you definitely can take it if you are really want to prepare for GATE exam. You will always have double edge. You will always have double edge by using this. Okay, so it is having multiple advantages. I used to say regularly for all other students also. If you have a chance, take the subscription. Okay, Unacademy is like a brand right now. This is the topmost educator application we are having in the country, no doubt in it. So we are having the batches in both the languages. You will be having the doubt clearing sessions, regular exams. So every single student we will serve the purpose. He is a beginner, he is a rank improvement, he is a final year college goer. For every single student we have a different batch such that he will be able to learn. So to take the subscription, these are the fees for us. 1 year may 25 and 2 year it is 30,000. You can use my coupon code Shankar10. What is the meaning of this, sir? You will get extra 10% on any course in an academy. Extra 10% you will get it for this price. Not only discount, you will get you. It means that you love our teaching, you trust us and joining an academy by seeing our teaching. That is the meaning of applying the code. or we will provide you the best possible guidance. That is me and my total team. So this is the code you can remember. Yes, Jogender, IPL sponsor is Unacademy only. It is a brand now. I hope you people knows it. So still, if you don't join this group, every day we are sending the notes to this group only. I have sent Thevenin's theorem yesterday class notes already. Up to superposition is sent, Thevenin's is sent, everything is sent here. Okay, just see the channel, go to files, you will get every single file here. Okay, so in this please understand here, I am every day sending, every day in the sense the topic is completed, I will send notes in this. So in the group, in the video description, you have this link, you can directly join to it. Okay, so right, let's go. So these are our channels, you need to subscribe for better updates. So if you are a Telugu student, you can opt for Unacademy Gate Telugu channel. Or Hindi English students के लिए Kreatryx Gate ECEE. So it is for everybody. It is specifically for Telugu. Previous questions is there. All other channels are there. Electrical junctions. Everything is there. According to your branch and all, you can select it. Right. So let's go to the problems today's session. Let's start today's session. So are you ready, guys? With all our energy, let's start doing the problems. Okay, so today's session I will be doing good number of questions on Thevenin's equivalent, Norton's equivalent, superposition theorem, whatever may be. Using some reciprocity may come which we have not discussed in the regular class, but for other students it will help, and for you also I will explain the concept behind that and I will do it. So these are the questions we want to plan today. So get ready, guys. Start with this question. Please keep your pen and paper with you. Every question I will give you some time to solve it. Think like a competition. Every time I give the answer, try to give the answer on time. Okay, every time I give you the question, try to give the answer. You may be committing mistake, no problem. Commit 100 mistakes of 100 questions, no problem in the class. If you commit more mistakes, you can learn more, but keep trying. Don't demotivate. I don't get the answer, sir. No need. You after 100, maybe in the next question, you may be getting the answer. Okay. So please, guys, do it. What is the question? Determine the Thevenin's equivalent of the network across a bit, right? No, Nani, today we don't discuss regular class. It is just a revision of the all previous classes. Like we do more and more number of questions and do it. Let's crack it. Guys, tell me what is the VTH, what is RTH? Do it. I don't ask you how to do it. Roy, first do it. You people try it. Okay, give your effort. You can learn definitely something from the class. No doubt in it. It will be a good practice for you also. It will be good practice for you of the basics. It can be like a revision who have studied. For those who are new also, they can learn. Everybody, it will serve the purpose. What's happening? I'm just waiting for your answers. Give your answer, guys. I just ask you VTH and RTH. Don't give anything else. I need only VTH and RTH from you people, right? Very good. Some Kanishka Rao gave some RTH value. Very good. Next, give me VTH value also. VTH 125, RTH 24.375. So different people are giving different answers. Let me wait for you guys. I am waiting. Everybody, every single student here, irrespective of your basics, do it, try it. You get it. Okay. So if you commit the mistake also, it is good. 1 minute. Yes, most of you have given right answer. VTH is equal to 125. Let me do the question. Let me do the question. Very good, guys. So let me try the question. So you are attending the other classes also today, or this is the only class? Today is a full day of marathon sessions. If you stay in our YouTube channel, you can see all the possible classes. And I will ask you again. I asked you to go through the my special classes of negative impedance and source impedance. Have you completed that part, guys? Please don't do neglect it. Okay, please complete the preparation on time. It will be helpful for you. Second class today is right. Good. So listen here. The one of the best way to do the problem is convert this delta. You can see this is a delta, na 15, 15, 15. Convert this into star. Here also this is a delta. You can convert this into star. If you do that, it is 15, 15, 15. Convert delta into star. You will get 5, 5 and 5. It will be easy for us because all are equal. Na? Conversion will give you by 3 by 3 by 3. Similarly, 30, 30, 30. What is the equivalent, sir? 30. Delta of 30. This is one resistor you assume. 30, 30, 30 will give you 10, 10, 10. In the basics class, I have already discussed this point. So the remaining part is as it is. You have a 10 and here you are having a 200 volts. Once you apply this, the problem is very easy. So you need to find the Thevenin's equivalent between AB. So just add these numbers 5 and 10, 5 and 10 here and 25. So what is the simple figure you will get is 200. This is 15. This is 25. And also it is again 15. This is the simple Thevenin's equivalent between AB. You know here I don't calculate all those things. My shortcut method is we know source transformation may in our lecture I have given you one shortcut. If you have a voltage source series with a resistance parallel with a resistance, what is the shortcut I have given? 1 minute, I will show you that. Just a minute, guys. Very good. See here, I already told you to all my students, once I start doing the problem, you stop practicing. If you do parallelly with me, it is of no use. Class is of no use for you. I already told you, na? So don't comment the answers. You can comment the answers until I start doing the problem. If I start doing the problem, just listen to the explanation. You tried it, it is over. Okay. So here you will be missing the methods and all. The purpose of the class will not be fulfilled. So voltage into V into series with resistance, parallel with resistance. I have given you one shortcut when we discuss the source transformation in regular class. Okay, this will give you 125. The formula is this one, V into R2 by R1 plus R2 series with 15 parallel with 25 is the formula. So हो गया आपका Thevenin's is completed. This is the circuit. So what is this 15 parallel with 25? Tell me, 15 parallel with 25 is 15 into 25 by 40. Let's calculate that part. 1 minute, guys. Right, very good. 9.375. So your problem is finished. Add these two, 24.375 series with 125. So you try by any method, it is up to your convenience. So this is the answer. This is your VTH. This is your RTH. Very good. So let's continue with the next. Okay. Please understand, Shubham, it is not voltage division principle. It is a shortcut I have given in the source transformation conversion. Okay. So those students who attended my classes, all they knows it. If you have doubt, please go through my previous lectures of source transformation. Okay, whenever you see a voltage source series with resistance, parallel with resistance, whether it is dependent or independent doesn't matter. You can convert this into current source parallel with two resistors. It can replace by a single resistor. Then you can replace again with this equivalent. This I have given in the class. If you have missed the earlier classes, please go through them. Thank you. So any issue, Jogender? Is it buffering, guys? No buffering now? Okay, let's go to the next question. Let's go to the next question, guys. Try this question and tell me the answer. Try this question and tell me the answer. See, I will explain you. This is a rectangular wire mesh. Each line is 1 ohm resistor. Okay, say like that. So, a rectangular wire mesh of infinite extent in a plane has a 1 ampere current fed into it. Okay, at a point A as shown in the figure, taken from the point C. Okay, here you applied 1 ampere. Here you taken the point 1 ampere, whatever you have applied. Find the current in the wire AC. Please try this question, guys. I am waiting for your answers. So different people are giving different answers. Just wait. Very good, very good. Most of you have given very good right answer. Very good, very good, very good. So the question looks complex, but the solution is very easy in this case. Question may look complex, but the solution is very easy. Let's do it. Let us do the question. So this is an infinite grid of network you are having. So please listen here. So here you apply superposition. By superposition, assume I have done this model 1 question already. As per examiner, assume 1 ampere is pumped at point A and second time you take 1 ampere is leaving. I'm sorry, it may not be visible for you. Right. First time क्या करना 1 ampere entering assume करना. Second time क्या करना 1 ampere leaving assume करना. As per the statement of the question. So अगर 1 ampere is entering here, if 1 ampere is entering here, इसमें 4 path है, 4 paths are there here. So the current divides into 1 by 4, 1 by 4, 1 by 4 and 1 by 4. Some people have given this as the answer. Just wait a minute. Okay. So this is first time. So let's take this current as I1. Let us take this current as I1. Now second time when it is leaving 1 ampere, It will be 1 by 4. I'm sorry. It will be 1 by 4. 4 paths are there now. 1 by 4 and 1 by 4. This is my I2. Total current I will be equal to algebraic sum of individual responses. The total current I will be equal to algebraic sum of individual responses. So what is the answer, sir? I1 is 1 by 4 plus 1 by 4. So 1 by 4 plus 1 by 4 is 0.5. You people may have the doubt, sir, why you took 2 times, sir? Why can't you take only 1 time, sir? Most of you have given 1 by 4 as the answer, right? Very good, very good, very good. So some people have doubt, please ask. Neha Kumari, no. Incoming is equal to outgoing, but it should not come from, it need not come from same branch. It can come from all other branches also. 2 by 3, don't remember Ramalakshmi, don't remember the questions, I mean answers blindly. That is a different question. Infinite grid, you need to find the distance between AB. The concept is same, but solution is not same. Okay, is it clear? So please listen, what I have done is simply this one. This is the figure given by examiner, right? So what I did is simple, listen here please. This is the figure given, right? As per the statement of the question, 1 ampere is entering here and the same 1 ampere is leaving here. That is entering here is 1 and leaving here is 1. Okay, this is the question. This part I have analyzed by 2 parts because you cannot have symmetry condition here. If this is the figure, please listen, you should not divide this current into 4 parts. It is 100% wrong. Some people will give that also. Because all are equal impedance paths, so current divides equally. No, you should not see immediate resistor. You should see up to the end. Here it is directly going to the end. Here it is going by a different path. So you should not divide here all into equally. Don't divide here 1 by 4. That is wrong answer. So that is what I told you earlier in the cube question, and when we do the superposition, may one question to find the resistance also. So please never divide here the current into 4 equal parts. That is valid, not valid, because this branch is directly connected here. This branch is not connected directly. So how can you divide equally the current? Don't see immediate resistor. Suppose examiner give you 1 and 1. Don't do that. Don't see immediate. You should see up to the negative terminal or end of the other terminal. Got it? Right. Roy, it is not who means examiner told. Point A and taken from point C. Examiner only given this information. Yes, one time it is entering taken, one time it is leaving taken. Ramalakshmi, that is given by examiner. 1 ampere is entering at point A and taken from point C. Okay guys, so let's move to the next question. So try this question guys, tell me your answer. Try this question, give me your answer. Give me your answer guys. It is doesn't matter whether it is AC or DC, Jogender, we can make it as a impedance and voltage. Voltage to current ratio is impedance. Maybe a phase and magnitude may differ, that's all. If all are identical, current divides equally. Very good, very good. You attend, Suman, you attended all my classes? Suman, have you attended all my classes? Very good, Suman Kumar. Suman Chitte, I am asking, have you attended all my classes? Yes, please go through it, attend all my basic classes. You don't get this kind of doubts in that case. Okay, please complete them. Okay, we take sum of all leaving currents is equal to 0. Is our KCL convention. You can take entering also, no problem, but accordingly you should write the polarities. You can take all enterings as equal to leaving, all enterings or all leavings as positive. It is up to you. So yes, A is the answer. Sandeep, good answer. Right answer first you have given. Who is given first? Suman Kumar has given first. Sandeep, right answer. Reddy, right answer. Arun, right answer. Very good, very good, very good. Next, Hrutik, Guddu, Momata, Sriram, Priyanshi, Sai Praveen, Hari Krishna, Saddam, Mahima, all has given very good right answers. Right, right, right. Okay, so see here. Determine the ZTH between AB. I will give you two methods to solve it. You have a voltage source, now replace it with a short circuit. Current source, just replace with a open circuit. Now, let us take the help of Laplace because examiner used the format, same we will be using it. Resistor is R, inductor is SL, capacitor is 1 by SC, current source should be replaced by open circuit, and again resistor is there 1. So you need to find ZTH here. What is ZTH, sir? These two are in parallel, sir. Between these two nodes you are measuring. Right, I have open circuited current source, short circuited voltage source. Now see here, these two are in series, these two are in series parallel. So 1 plus S into 1 plus 1 by S, which will give you 1 plus S into 1 plus 1 by S by 1 plus S plus 1 plus 1 by S. Calculation part you do, you will get 1. After multiplication of that equation, you will be getting 1. This is one method. Okay, if you have some basics of transients, which we discuss later, for time being, I am saying that this is the figure given now. In this figure, if you replace with short circuit, this with open circuit, okay, inductor should be replaced by short, capacitor will be replaced by open. This is for a DC. I'm sorry to draw like this. So for DC, inductor should be short, capacitor should be open, voltage source is short. Just a minute, just a minute. Right? Listen. This is also another way to solve this question. What is that, sir? For DC, generally steady state inductor should be replaced by short, capacitor should be replaced by open. We discussed this in the transients later. So if you replace this with the open and replace this with a short, then you will calculate PQ ka beech mein resistance. What is the resistance ZTH? It is open, neglected, only one. Directly you can say like this. This is a direct method, or go by Laplace, inductor with SL, capacitor with 1 by SC, and do the question, you will get the same answer. Otherwise, a direct method, any method is okay. Because the input is DC, in this way also we can do. Right? Yeah, this process every time you can apply. That we can apply for DC. Thank you. So let's go to next question. Are you ready, guys? Are you ready? Sai Praveen, if your answer is wrong, no need to delete it. Keep it as it is. It doesn't matter. Okay, no problem. Give wrong answers also. Right. See, most of the students will feel difficulty. Most of the students will feel difficulty whenever we discuss a problem with boxes in the network. Let's do more number of this kind of box questions. Let us unbox this box questions. I'm get ready with these many number of box questions. For you, I have made it. All the questions boxes are ready. So we will do all these questions today. So let's try them. Before that, okay, let's do this question also. Let's do this question. You people tell me what is the RTH here. Okay, I need quick answer here. Very quick answer. I need very quick answer. Tell me what is RTH. I like this question very much. Simple question. No problem. Keep doing, Sachin. First, complete my all previous classes perfectly. You will definitely able to do it. If you do my previous classes completely, this question will be like a good practice for you. If you have not completed my previous classes, you may face some little difficulty. But I suggest you, please complete them as early as possible. Then you will be in regularly. You can attend the live and learn the subject in the best possible way. So, guys, please read this. Try your answer. Try your luck. So different people are giving different answers. Let me check it. Let me wait for the right answer. So finally, how much? Okay. How you have done this question? How you have done this question? Let's check it. How you people have done this question, right? So let me try this question for you. So now listen here. This is the figure given. If you apply voltage V here, assume current I is flowing. What is RTH, sir? V by I. If you apply node analysis and all this, it will take so much of time. If you apply node analysis and all, it will take so much of time. Then what to do, sir? What to do? Listen here. Mesh analysis, loop analysis, everything requires more time in this question. You can definitely do it. But there is an alternative method to solve this question here. Because your dependent variable Vx and V are same. Your Ix is, if it is Ix, na, this is also ix and I also same. So can I say Vx by Ix is the same as V by I? Because V equal to Vx, I is equal to all the division, all those things happens. Count finally whatever the current comes is Ix only. Okay, you cannot find VOC by ISC RTH here. Please listen here. First listen, simple method. Simple method. What is the simple method, sir? See here, this question may find Vx Ix ratio. Simple. Apply KCL at this node. Problem will be solved. One step में answer आएगा. One step में आपको answer आएगा. Let me draw it in the next page. Single step answer. Listen here. What is this current, sir? Okay, some I you take. What is I, sir? KCL. Leaving current is I. Another leaving current minus 2 times Ix. Entering current minus 0.01 Vx equal to 0. Okay. So I is equal to 2 times Ix plus 0.01 Vx. Next, at this node apply KCL. This is I now. So by KCL, it is everywhere I am applying KCL only. Entering current is I. Okay. Entering current is I. 1 minute. Okay. Ix is not 0. Please, who is that? Dinesh. You should not take open circuit condition. You should apply the source and check the condition. You should apply the source and check the condition. Okay, don't do that. So now here, find Vx and Ix relation. You got one thing. Another single step may listen here. This is how much? Minus 2 times Ix. Okay, these two are entering. What is the leaving, sir? I minus 2 times Ix. What is this current, sir? If it is I minus 2 minus Ix, this is went now. So I minus, let us take this. I'm sorry, 1 minute, guys. I1. Okay, I'm very sorry. Now listen. This is the current. This is the current, and this is leaving. Subtract it. I minus 2 Ix minus 0.1 Vx. So here you apply KCL. Problem is solved. So what is that? Minus I1 minus I minus 2 times Ix plus Ix equal to 0. From this you find Vx and Ix ratio. Okay, let me check if I have committed any mistake in the KCL. Guys, 1 minute. So this is 2 Ix is leaving, minus 2 Ix is leaving. So I can write this as 2 times Ix is entering. So at this node, I1 equal to 2 Ix plus 0.1 Vx, right? So this is I1 entering like this. This is I. If it is minus 2Ix, what is this current, sir? Sum of these two will come here. I minus 2Ix. It is gone. I minus 2Ix minus 0.0 V1. Here I applied and find Vx by x. Okay, right? So it is a simple KCL only. Next, 1 minute. Tell me the answer for this question. Find RTH here. Any doubt in that? 1 minute. What is your problem, Jogender? It is minus 2Ix is leaving. So 2Ix is entering, right? So KCL entering current equal to leaving current. So I1 equal to 2Ix plus 0.01 Vx. What is the problem in this? So similarly here minus 2Ix is entering, I is entering. Leaving current is equal to sum of these two. That's all. Don't confuse with KCL. Okay. Is it clear? — 1 minute. Try this question. Yes, Sachin. 100. Finally, your answer will be 100. You try this part. Now do this question. Try this question, guys. Here, what is RTH? What is RTH here? Try it and tell me the answer. Okay. 250 by some different answers are coming. Okay. How you did it? That is the method. So you can apply multimeter method. Apply voltage V. Find the current I. What is RTH, sir? V by I. Okay. 1 minute. 1 minute. So what is the drop here? 25 I1. Because I1 is coming here. Then what is the drop here? By loop equation, if it is 15, if it is 25, this should be 10 times I1 by to satisfy the KVL. If it is 10 times I1, what is this current, sir? 10 times I1 by 100. Let me little zoom. Okay. So see here, this is the figure given by examiner. So I1 is given by examiner, so it is 25 I1. So if it is 15 I1, so to satisfy KVL, it should be 10 I1. So 10 I1 by 100 voltage by current ratio will give you a resistance. So that problem, now it is the 10 I1 by 10. So what is the resistance of the dependent source here? Rx is equal to voltage is 15 I1, current is how much? I1 by 10, because the 0 0 cancels. So what is the answer, sir? 150. Problem is solved or not? So what is the RTH is equal to 5 plus 25 parallel with 100 plus resistance of the dependent source. 5 plus 25 parallel with 250. That is 5 plus 25 by 11. Whatever you get, take it. Very good. So is it clear? The way we solve the question different compared to the regular method. Regular may node analysis say you can do it. Definitely by using node analysis 100% you can solve this question by node analysis. But I am not solving by node analysis. Simple method is what? I find the tricks like that. If I1 is coming here, it is 25 I1. Then it should be 15 I1. So to satisfy the KVL, it should be 10 I1. So voltage by resistance will give you current. That is I1 by 10 will come here like this. So that is the resistance of the dependent source is voltage by its current I1 by 10. I1 cancels, 150 will come. I1 will cancel and 150 will come. So this you can replace with 150. Arrow direction positive to negative, positive impedance. So 250 parallel with 25 plus 10. Right? Very good, very good. Now 1 minute. Let me give you some, let me remove some misconception from your mind. Most of the people will have this misconception. 100. My dear friends, listen here. This model already I have done once in our last session also. But I want to give you one thing from this class. Same model I am taking. I have done this question, I know it, but here I want to give you extra point from this question. So let me give you that point. So because it is a most misconception in so many people, so I want to give you this. So find RTH is the question. For example, what is the question? Find RTH. So what you people do? You means everybody. You can find VTH by ISC one method. Else, replace this with a short circuit and connect the figure as it is. 1 minute, guys. I want to show some common mistake in most of the students. That's why. So listen here. This is the figure. Replace this voltage source with a short circuit and find the RTH between AB. What is RTH, sir? Okay. So some people will do like this. How, sir? Listen. So some people will commit the mistake like this. These two are series, sir, same resistance. So Vx. They take this current 0. Assume this current as I. If this current is 0, na, this is also I, this is also I, this is also I only. Assume this as Vx. They apply KVL and they take Vx equal to 0 and I is also equal to 0. This is wrong approach. Okay, if you take Vx equal to 0 because there is no current open circuit mein, and in this loop if you apply KVL and you take Vx equal to 0, I equal to 0, then they will say this is replaced by short circuit, then 2 parallel with 4, 4 by 3 is the answer. This is the most common mistake people will do it. Earlier also some people gave me the answer here also. They take this current as 0 and do the analysis. No. What is the meaning of resistance is not when it is open circuit. It is open circuit resistance only. But meaning of the resistance to calculate is, please listen carefully. What to do is, see here, to find the resistance, you should apply voltage and assume current is flowing, then this is I. Okay, if you take this current as Ix here, this is Ix here, you should take this current as I plus Ix and do the analysis, then it is right. If it is RTH, it is V by I. This is the method you should apply. Never take, because it is given like this, I will take this current 0, sir, and I will do the problem for RTH. No, wrong. RTH ka meaning kya? It is the resistance looking into this terminal. Means if you apply some voltage, how much current will flow? That ratio will give you the resistance. Don't take this as a 0 and calculate the resistances. Please understand that point. Is it clear, my dear friends? You can ask it. So, right? Is it clear, my dear friends? Everybody here, tell me, yeah. This question already we done last time. If it is Vx by series, it is also Vx. It is 2Vx. Okay. If it is 2Vx, it should be 3Vx to satisfy the KVL. Then this current is 3Vx by 2. I told you already this. I am not doing it again. But if you want, what is the resistance of the dependent source? Voltage by current, 3Vx by 2. Okay. Then what is the R equivalent? 2 plus voltage is 3Vx by current, 3Vx by 2 plus 2 by 3 parallel with 4. That is 8 by 3 parallel with 4. You will get 2 as the answer. Is it correct? 32 by 12. 1 minute, guys. Just a minute. This is the question given, right? Vx, if it is also Vx. Yeah, 2 is the na. Okay, whatever you get it, take it. Whatever you get, take that value. I think 32 by 12 will come. Yeah, whatever the value comes, take it. So please understand here. Is this main point is clear? Don't take this current 0 and do the analysis. Never do it. We should connect some source, find V by ratio. Okay. So if it is all force, it will give you 2. Don't remember that answer. We did that question. It is all force. Here it is not all force. Okay, whatever you get, take it. No problem. So come back. Okay, finally do this question, guys. Finally do this question. We will move to the next. Boxes models. So do this question, then we can move to the box model. So unknowingly our 1 hour is completed. Half of your time is passed. If you are actively involved in the class, you never mind about the time. You never mind about the time. If you do the problems with energy and all those things, you will stay connected to the whatever may be the time of the class. So guys, just go through this question, try the answer. A, B, C, D. Quick guys, try it fast as possible. You can definitely do it. Try it, man. Answer A, B, C, D. Tell me the answer, guys. Why this much delay? Directly by seeing you can say. Directly by seeing you can say, man. So Mamata Agarwal gave the answer as A. So what about you guys? Remaining guys, tell me. Remaining students, every single student, tell me, yaar. Network issues. What happened here, Sachin? So remaining guys, to commenting, what happened here? 1 hour to pass hua. So be energetic, guys. I need your energy to be sustained. Sustained energy is required, not damping energy. So some students so B आया, some students so what is that? Here also don't make I1 equal to 0, guys. Don't make so some people will do like this. It is I1 sir, this is 99 I1 sir. Here I will take 100 I1 sir, and it is equal to 0 sir. I1 is 0 sir. No sir. While finding VTH it is correct, not for RTH. Okay, flood. Where it is, Sachin? So many people got B, but I think B is wrong answer. B is the wrong answer. I hope A is the right answer. Let's check it. Fine. Why to find? How to find VTH? Make this current 0. Open circuit voltage is VTH. Open circuit voltage is called VTH. Okay, very good. So VTH is equal to open circuit voltage. So if this current is 0, by KCL, I1 plus 99 I1 equal to 0. Then 100 I1 is 0. What is I1 sir? 0 sir. Here I1 is 0. Then what is this drop? 0. Then what is VTH? 1. VTH is 1 everybody. Okay, Odisha. Right. VTH is 1 everybody accepted? Accept kiya nahi kiya? Find ISC. I will give you ISC is equal to now after these many number of questions you never should not get any single doubt when Thevenin's questions comes. Thevenin superposition ka questions aaye to you should feel very comfortable. So for finding ISC short circuit this. As per examiner this is I1. You need to find ISC. What is ISC? It is equal to 100 times I1. If you take this node voltage as 0, what is I1, sir? I1 is 1 minus 0 by 1K, which is 1 milliampere. This voltage minus this voltage by resistance, 1 milliampere. Then what is ISC? 100 I1. 100 I1 is equal to 100 into 1 milliampere is 0.1 ampere. Then what is RTH, sir? VTH by ISC. 1 by 0.110 ohms. If you are not comfortable with this, no sir, I want to do, I am different, I don't want to do by conventional methods. I directly want to find RTH without doing this much story. Yes, you can do. How to do it, sir? Replace voltage source with a short circuit in this figure and connect the remaining network as it is. That is I1. And here 1K. Here how much? 99 I1. Okay. So two elements, if you want, you can take here I and V. Okay, please listen here. Everybody carefully listen. Current is in the ratio of 1 is to 99. It is 99 I1, it is 1. So resistance will be in the ratio of 99 into 1. Will you accept this or not? Current is in the ratio of 1 is to 99. Then the resistance will be in the ratio of 99 is to 1. Right? So what is the resistance of the dependent source is 1K by 99. So what is the R equivalent, sir? 1K parallel with 1K by 99. It is simply 1Ks are in 99, 1Ks are there and another 1K. It is simply 1K by 100, which will give you 10 ohms. Direct answer. Okay. How 0? For finding RTH, we should make independent source equal to 0, guys. Roy, is this clear? This is how I calculate. How I calculate? Simple, listen here. It is I1. It is 99 I1. Current is in the ratio of 1 by 99. Resistance should be in the ratio of 99 into 1. So it should be 1. This resistance should be 1 by 99 times this one. So 1K by 99. So 1K by 99 can be indirectly called as 99 1Ks in parallel. And this is another 1K. Total 100 1Ks in parallel. So don't do this calculation. Simple straight steps. 1K by 99 is equal to 99 1Ks in parallel. It is another 1K. Total 100 1Ks in parallel is the easiest way to do this question. 1K by 100 10 ohms. No sir, I am not comfortable. No problem. I will give you another method. See here. If you take this as V, what is this drop, sir? 1000 I1. Okay. Now you tell me what is V? V is equal to minus 1000 I1. Another method I am giving you. Then what is the resistance of the dependent source is its voltage by current ratio, that is arrow direction opposite, minus V by 99 I1. What is minus V, sir? Minus of minus plus 1000 I1 by 99 I1. You do by any method, guys, answer is same, 1000 by 99. So node analysis you apply, anything you apply, finally you will end up with the same answer. Very good, Gaurav. Okay, is it clear? Is it clear? While this node, whenever you short circuit this node, it is always 0 only. 0 volts here. Parallel mein voltage is same only. Roy, okay. For finding VTH open circuit, these two terminal, this current is 0. Then apply simple loop equation. Entering current should be leaving current. So I1 is 100. Then if I1 is 0. Then if it is 0 volts, parallel mein voltage is same. VTH equal to 1. Apply your basics in a proper way. Every question you can solve in the best possible way. Is it clear? I solve any single question in the sense most of the questions in a best possible different ways, because I invested more and more time on networks only. Instead of teaching n number of subjects, we teach it is generally 2 subjects. In that, in best possible way, all the possibilities I checked and I tried, I invested my time. That is what I am giving to you. Utilize it properly. Okay, this is a different ways to solve the question. Okay, please don't think it is lengthy. It is two ways to solve the question. One step का answer मिलेगा directly by seeing you can say. If you have good enough practice. If you have good enough practice by seeing the question you can say. Let's do this question. Thank you, Mamata. Bharati. So let's try this question, guys. Okay, I will give you homework is try by superposition theorem. Three sources are there now. Take one source at a time and apply your superposition friend. He will help you, no problem. Okay, another method is Thevenin's method. Let's do this question by Thevenin's. Will you try it? Shall I give you some time or shall I explain it? Thank you, Gaurav. Tell me, will you try the question or shall I give you time to try or shall I answer the question? Shall I explain and you people want to try? What happened? Give me the comments. Okay, you want to try? Just I will give you a few minutes of time. You people can try the question. So, guys, I hope if around out of the 123 students, around 100 students of mine are attending every class regularly. Some people are attending in the live, some people may be attending recorded. So, those who attended every single class of mine by this time, you will be having some comfort in the network. Like earlier, compared to earlier, definitely now you might be performing well. Now you might be performing definitely well. You will feel the difference. But if you are coming to the classes not regularly, some classes you come, some classes you skip, or intermediately you come, you may not like my class because every class I discuss is based on the previous class, whatever we discussed, those concepts I will apply. So if you are new to the class, I suggest you complete the playlist of the network analysis. It is in our Kreatryx channel. My all basic lectures are there. Please complete them. RTH is 11 point something. Okay, fine. VTH is how much? VTH is how much? So try it, guys. Keep trying. You can do like this. Hint is remove this resistor. Remove this resistor. Remove this resistor. Find. Apply source transformation here. Node A, node B, node C, and node D. Okay. Between A and D, you have this connection. This is 1 ampere. What is this? 10 volts. And here source transformation of A to B na. So arrow direction is negative to positive. This is A to B. Current into resistance is 2, 1. This is A, this is B, this is D, and this is C. So you need to find the Thevenin's. between B and D, between these two nodes, B node and D node. So between here and here, you need to find the VTH. This is my method. Different people will go by different ways. I am going by this method. Okay. So if it is 1 ampere, now the question is one step mein ho gaya na? 1 ampere. So this is also 1 ampere. So current enters from positive, leaves from negative 1. So what is the answer, sir? You should apply KVL here. Sorry. It is positive, negative. 1 ampere means 5 volts. So now see here how simple the question is. Okay. So you need between VTH these two nodes, negative to positive 10, positive to negative -5, VTH is equal to 5 volts. Just apply KVL, you will get the answer. By KVL, VTH will be equal to 5. Yes or no? This is like this. You are having negative to positive 10, positive to negative -5. Whatever, this VTH must be equal to 5. Okay, what is KVL? 10 minus 5 minus VTH is 0. What is VTH, sir? 5. One step में answer आया VTH का, ISC का answer. How to find ISC answer? Or ISC is not required. Find RTH directly. Replace current source with a open circuit. This is one. Voltage source is a short. Current source is open. So what is RTH, sir? Is there any distance between A and C? 1 minute. Yeah, I am sorry, I forgot that. I'm very sorry for that. Between A and C, there is a resistor. I am sorry. I am very sorry. Between AC, yes, one resistor is there. In that case, it takes little more time. I am sorry for that. I am very sorry. Right. Okay. This is the circuit. For finding RTH, you can find easily. For finding RTH, what to do? This is 5. Replace voltage source with a short circuit. I'm sorry. This is resistor 1 ohm and short circuit this and current source को open circuit it and here 1 right. So where you are measuring between these two terminals. Okay. So what is the answer here? 2 parallel with 5, that is 10 by 7 is RTH. Yes, everybody right answer. Next, now how to find VTH, sir? Apply node analysis. We don't have any alternative here. Okay, if you take this node voltage as V and you take this as your ground, you can do it. Can you do this part or shall I explain this also? Please tell me, if required I can explain. Just a simple node equations will give you the answer. If you take this as V1, V2 equations, you will get the VTH value. I hope you can do this part. Okay. Otherwise, I'll write the equations. You try it. V by 5, V minus V1 minus 2 by 1 equal to 0. First equation. Second equation kya? At this node. Okay. V1 by 1 plus 1 equal to 0. Simple equations. Two loop equations. Say you will solve it. You get V and V1. Okay. This is 1 minute. It is V1 with respect to ground. Okay. Leaving is 1 ampere. V1 by 1 is 1 ampere. Okay. So from that you will get the V1. Substitute you will be getting V. Okay. Or you take this as ground directly, your V will be equal to VTH. Any method you can try it. Is it okay? What is VTH, sir? This total voltage. This total voltage is VTH. You try that part. So next question. Good, Namrit. Right. Do this question, guys. Try this question. This question is relatively easy. Please tell me the answer. Please tell me the answer. Relatively easy question. Just tell me the answer. Tell me, guys, your answer. Yeah, box questions will come, Suman. After this, mostly box questions will come into picture. That is the last part of our class. Very good, very good. One step में आपको answer मिला. Very good. What is the answer? Is 0. It is a very simple question. What is V, sir? 7. It is given in one of the IES paper. 3 cos 2t. What is V, sir? 3 cos 2t plus 7 e power minus t. Examiner want, this is your V of t. This is your V of t. You need to find the instantaneous power delivered to the 5 ohm resistor. This is V of t. If you substitute t equal to 0, what is V of t, sir? 3 cos 0 plus 7 e power minus 0, which will give you 3 plus 7, which is 10. Then what is the power of the 5 ohm resistor? Time t equal to 0 mein, what is the power? Is 10 square by 5, 20 watt. Instantaneous power ka meaning is power at that particular instant of time. Here examiner want at t equal to 0. Just substitute t equal to 0, find the voltage, calculate the power. He is not asking average power or anything. Here he asked the power is instantaneous power. He don't ask the total power dissipated, nothing. Here he asked instantaneous. That is the power at the instant time t equal to 0. Very good. Nice. So let's move to the next. This question. So we are entering into the box questions. Before that, 1 minute, guys. Can you take this question as a homework? You need to find the current I. This is the I. This is the current in the 50 ohm resistor. Can you do this question? It is not a balanced bridge. 30 by 10 is 20 equal to not 10 by 15. How to do it, sir? Try by KCL and KVL. Can you do this question? Symbol is there, Roy. It is voltage source symbol. And this is the current source symbol. Yes, this is the homework for you guys. Try it. So now come to your friend box questions. Yeah, let's do this question, guys. Tell me the answer for this. You just whatever you feel, give me the answer. I will do it definitely, but first you try it. Tomorrow we have class of logic circuits, that is a digital circuit design. Suppose you have a logic circuit with propagation delay, how to deal with those kind of questions we can discuss tomorrow marathon session. My class is from 6 p.m. to 8 p.m. You can attend that class. Digital circuits. 1 minute, let's clear Jogender doubt. Just a minute, guys. What is your doubt, Jogender? Please tell me. Please tell me what is your doubt, Jogender. Jogender is happy. Any doubt you have, just apply KVL. Don't minus plus में कुछ confusion नहीं होना चाहिए. Negative to positive, positive, negative to positive, positive, positive to negative, minus. That's all. Okay, let's go to the question. Yes, tell me the answer, guys. A, B, C, D, E. What is the right answer? A, B, C, D, E. What is the right answer? Tell me the answer, guys. One minute. Try it. No problem, Suman. I will do it. Just wait. Remaining students, tell me your answers, guys. Option D, option E. Different people are getting different answers. Okay, let's see what is the right answer. It's 8 comma D according 8 comma 8 according to me. Let me try this question. First point. What is the first point given by examiner? I equal to 0, equal to 4, I equal to 2. That is, the input current is 2 ampere and you have a resistive network, linear, passive, bilateral. When current is 0, the voltage here, this E is equal to 4. This is what we call Thevenin's voltage because the current 0 voltage between the terminals is called VTH. What is VTH? The open circuit voltage measured across the terminals. Because I0 में whatever box question are very easy. Just use the information as it is. Problem to solve हो जाएगा. Similarly, second information क्या? I is equal to 1, E is equal to 4, I is equal to 2. So now see here. This is the same 2. Okay. So here the network is there. When he applied, oh, I'm sorry, options you forget it. Okay, 8, he got 1 amp. Everybody accept this or not? I just made the figure according to the information given by examiner. Up to this, no doubt na. Then I will tell you how to do it. Don't worry. Firstly, tell me up to this, is there any doubt for you or no doubt? Tell me here. I'm waiting for your comments. Tell me your answer. If you are clear up to this, then I can move further. Otherwise I cannot move further. Very good. No doubt, no doubt. Clear, clear, clear. So now what to do is I will just replace this part with its Thevenins. Replace this with its Thevenins. What is the Thevenins equivalent, sir? VTH series with RTH. VTH series with RTH. This is the Thevenin's equivalent of this network. For this, as per examiner, he has connected 8 volts. He got a current of 1 ampere. He got a current of 1 ampere. Now, listen. You know already VTH. What is VTH? You got it. Now, what is this? 8 minus 4 by resistance RTH equal to 1 ampere. Then what is RTH, sir? 1. So from the given information, I am able to find VTH, I am able to find RTH. Don't take this ratio 8 by 1 as the RTH. RTH is the resistance measured when independent source is made equal to 0. Examiner has not given this current as 0. So this ratio is not RTH, guys. So be careful. You should take this as it is. Now this replace with VTH and RTH. Because input is present now. We should take VTH series with RTH. Now RTH is obtained. VTH is obtained. Now question is not same. Please wait. The question is if determine VTH, ITH, if A and B, if I equal to 4. Please listen now carefully. When I is equal to 2, your VTH is 4, RTH is 4. But if I is equal to 4, what about VTH, sir? Now it will be 8. What about RTH, sir? Same. Because the Thevenin's resistance is independent of the input you applied. Whatever may be the input you apply, the voltage will be, resistance will be same. Because the definition of RTH is the resistance measured when independent source is made equal to 0. VTH will double when input is doubled by homogeneity principle. Because it is since resistive network. Later in the next classes when we discuss reciprocity, then we will discuss reciprocal, non-reciprocal networks. Sometimes it is possible to multiply directly, sometimes it is not possible to multiply directly. All those conditions also we discuss. There is a use of 2 ampere for finding this VTH. Using that only we obtained the answer for 4 ampere. If this is not 2, you cannot take this 4. Okay, you understand that because these 2 are 2s only, we took this VTH. Every information is useful here. So what is the answer, guys? 8, 4 is the lock answer for you. Is it clear, guys? Yes or no? Box wala questions में some confusion will be there. So you don't worry about much about it. It is easy if you use the information properly. So shall I move to the next question? नेक्स्ट क्वेश्चन चलेगा. वेरी गुड. Right. So last step, input is multiplied by 2. Original input is 2 na, input is multiplied by 2. Your VTH is also multiplied by 2. Input is multiplied by 2, VTH is also multiplied by 2. That is the last step. Input is multiplied by 2 times, VTH is also multiplied by 2 times. 4 has become 8. Okay, good. So let's move to this question. Try this question, guys. Read this question properly, you will be able to understand and answer it. So read the question, guys. Read the question and tell me the answer. I am just waiting for you. Last 20 minutes of the class. Last 20 minutes of the class. So be energetic. We will learn more things in the last only. I kept important questions in the last only. So attend, learn in the live only. Finish it now itself. Don't deviate unnecessarily. Right, guys? Please tell me the answer. I will read it if my writing is not comfortable. I will read it. You have a network 1 and network 2. Okay, I have made it printing, but still some mistakes are there. Instead of that, I took extra effort for you people to write all these things. So instead of writing in live, if I write it early, I can save time and I can give you more. So please utilize this properly. Attend in live. We will give you more and more initiatives. So see here, Thevenin's is applicable to the network N1. Okay, N1 is a linear network. Even if N2 is non-linear. For example, network 1 is there, network 2 is there. You want to apply Thevenin's. Is it required the load should be linear or not? Those are the questions. First one is, when N2 is non-linear, can you apply it or not? When N2 contains inductance which is coupled to N1, can you apply it or not? N2 contains a dependent source whose value is depending on V and I of N1. An element which is linear but mutually coupled to N1. So please understand here, in these cases, Thevenin's is not applicable. This case may Thevenin's is applicable. N2, that is the load, you can say. This you can take it as a source, for example. You can convert this into Thevenin's provided this load is not having any dependent variable in the first network. Then you can apply Thevenin's. Simply source transformation, I told the same thing. Na? If you have a dependent variable, don't disturb that source. Same way. If you want to convert the network into Thevenin's, the load can be linear or non-linear, it doesn't matter. Load can be anything, happily you can apply. But what is the required condition? Load should not be having any dependent variable on the first network. Okay. So please listen. Which question you asked, Ram Lakshmi? Okay, Ram Lakshmi is having some doubt. Let's clear her doubt. Please understand here. In this case, current is same. That's why I took VTH same here and here. Second case, current is doubled. So I made VTH is doubled. RTH is independent of input because what is the definition of RTH? It is the resistance measured when independent source is 0. RTH never depend on the input. RTH depends only on circuit values. When you find RTH, we always make whatever may be the input, we make it equal to 0 and calculate it. So RTH is fixed. VTH will be doubled because input is doubled. Linearly, homogeneity principle say, because it is resistive network. If source is non-linear, Thevenin's itself not applicable. I told that where you apply Thevenin's? Thevenin's is applicable only for linear networks. This should be compulsory linear. That is the first thing. N1 is linear. Thevenin's is applicable only for linear networks. Second part can be linear or non-linear but should not depend on the first part. Simple rule. Is it clear, guys? So what is the right answer here? A. So this is one of the important or good question. So let's do simple questions again. Now tell me what is this answer. This answer everybody should tell me. Every single student should tell me. Yes, Ram Lakshmi. You just have you attended superposition class? There I have given homogeneity principle. Same thing. Have you attended superposition class of me or not? Please tell me that. Why different people are giving different answers? Yes, I am very happy. Most of you are giving right answers. Most of you have given right answer. Current source means open circuit. Voltage source means short circuit. RAB or RTH equal to 2. Simple question. ज़्यादा टाइम नहीं चाहिए ये. So next this question, tell me. This question you tell me. Right. Here it is a very simple question. By seeing dependent source, don't worry, never worry. What is I, sir? V1 by R1. So this part, this current is 0 now. This is directly equal to alpha I parallel with R2. This can be written as, just compare this with our method ISC parallel with conductance Gn, which is 1 by Rn. So what is ISC, sir? Opposite direction, na? So it is minus alpha. That is minus alpha into what is I? V1 by R1. What is the conductance Gn, sir? Here it is resistance, so 1 by R2. So where is that option? Very good. So simple question. This current 0, this you can remove this part. What is alpha I? What is I? I is V1 by R1. Substitute it. Then you just compare with the Norton's equivalent. This is one method, or do short circuit, find V by ratio. That is also okay. Okay. Right. Next. Do this question. Try this question, guys. What happened to your energy, guys? Just stay for 15 minutes. I will give you the best possible. All your misconceptions or all your doubts in your Thevenin's Nortons will be cleared by this day. Okay. So don't decay your energy. Just stay for 15 minutes with high positive energy. You will be learning the things much better. Okay. So stay high. Stay high. Okay. So don't deviate. It is a matter of 2 hours for you. Okay. Just listen. It will give you something for your preparation. So whatever, however energy you are having in the first few minutes, you should have the same energy at the last few minutes also. Right? So do it. Amrit, yeah, in 15 minutes I can say that. Aishwarya, what is your doubt? There is nothing is neglected here. It is the Norton's equivalent we have calculated. Right. So here, yes, E equal to 10, I equal to 1 ampere. Then if VCD equal to 100. So 1 minute here. When this is 10, it's a linear network. Okay. The current I is equal to 1 ampere. And if VCD is equal to how much? Okay, I'm sorry. Actually, it is a reciprocity theorem which we have not discussed in the class. Let me leave it. Okay. This is 1 ampere. So as per examiner, he applied here 100. He want this current. Okay. What is this current? The ratio of this to this always equal to this to this. That is 1 by 10. We discussed it in the reciprocity. For time being, just to continue this part. I will be 10. Yeah, it is reciprocity theorem. Regular class we have not yet discussed. So that's why I am not discussing much about this question. So these are also there the box kind of questions. This also I can discuss more with the help of reciprocity theorem. And some more box questions are there. Let's try. It is also reciprocity theorem. So in the reciprocity, we will be discussing these questions again. Whatever the box kind of questions are there. Few more are there. Just wait. Let's do this question. What is VTH and ISC? Tell me the answer, guys. What is VTH and ISC? At A comma B. At A comma B, what is your VTH and ISC? Pramod, we will discuss reciprocity is not yet discussed. We will discuss it in the next lectures, upcoming lectures. Pramod, for time being, don't worry about it. After maximum power transfer, I will discuss what is that is maybe in the Monday or Tuesday class, we will be discussing that. Don't worry. Monday maximum power transfer will be done, and Tuesday or Wednesday we will be discussing reciprocity. Right. So what is the right answer, guys? Again, some people still giving the answer as what is that? Some people are giving B, some people are giving C. What happened here? Right here, one step में आपको answer मिलेगा. What is this? V is equal to 25 when current I is equal to 0. This is called as VTH. VTH तो मिला. Then I is equal to -5 when V equal to 0. Voltage is 0 means what? Short circuit. Current 0 means open circuit. I equal to -5. Now that is you can draw this figure. It will be like this. This is -5. But your ISC is in the downward direction. In the load current, na, ISC is this one. So can you tell me what is ISC? It is +5. Then what is RTH, sir? It is VTH by ISC. That is 25 upon 5, which will give you 5 ohms. So that is the right answer. Here don't take -5, tempting answer. I is here entering current. What is ISC is the load current, that is leaving current. You understand? ISC must be in the downward direction in the load. Okay, it is not negative. We should be careful with the direction of the current. Okay. Very good. Next. Let me give you the last question for today's class. Last question for today's class. Just give me 1 minute. I will give you the last question for today's class. Get ready, guys. I hope you enjoyed the session. You learned something new or some more techniques to solve the problems today. So I have made enough practice for Thevenins and Nortons, guys. So you utilize this properly. Attend the classes regularly. Do your practice part also. I shared Thevenins. The notes is shared. This marathon session also. I will share the notes immediately now itself. I mean after the end of the class, I will share you that also. Just a minute. I am searching. I mean I am taking the question from the questionnaire. So let's complete the last question for today's class. I have one question I'm missing. I'm waiting for that. Just wait. Right. So one more box question to end the class today. So you can enjoy your weekend. Few more classes are there. I think you can enjoy those classes. Then tomorrow we meet again. Sunday we will enjoy again at the evening, 6 p.m. I already told you about my special classes last lecture also. Please complete them, guys. You will learn definitely some new things. Those are completely free for you. In registers and counters, I have done some special classes. All special classes I have done for free for you. Just go through it. So this is the question given by examiner. So that you will your doubts will be cleared by this question. Okay. So find VTH, ISC, RTH. I hope everybody can do this question. Then you can do it. I will end the class. Just to do this guys question, guys. I am waiting. Resistance can be negative also, Roy. It depends on the network is active or passive. We have done those questions also. RTH can be negative also. For passive network, it cannot be negative. Very good, Ramesh. You are correct. You also enjoy your weekend, guys. Why not? Generally, we plan marathon session every 2 weeks so that it will quickly revise all your previous things also. So guys, please share this session to maximum number of students. Share my playlist of the networks to maximum students so that more number of students will get benefited freely. Okay, that is what I want to say. In YouTube, go to Kreatryx channel, go to the playlist. My total network playlist is there in that. Just share that link. Every single student can learn from that. So network will become so very easy for you. Right. So it is a simple regular similar question only. If you apply Vs equal to V1, it is a resistive network. V equal to 0, open circuit it. Current, sorry, V equal to 0 means what to do? Short circuit it. Current is equal to -5. So from this you find ISC. What is ISC, sir? 5. First part to ho gaya. Second part what? When you make Vs equal to 0, okay, here you applied V equal to 1. Current I is equal to 1 by 2. What is RTH, sir? RTH is equal to its V by ratio when independent source is made equal to 0. So what is that? 1 by 1 by 2. That is 2. So what is VTH, sir? 5 into 2, 10. So that's all. This is the VTH for this input. You by default you should understand for this input only examiner asked. If nothing specified. Very good. It's a that is the box model. Few questions will come. Critical questions are there. Good number of questions that will come after reciprocity. After our reciprocity discussion, I will come back to that in our either Monday class or regular class. We will be doing it. So see here tomorrow. Champagne 6 p.m. say 8 p.m. We have 2 hours digital circuits. English only. It is in English only. इंग्लिश और हिंदी चाहिए तो हिंदी मिक्स करेगा तेलुगु चाहिए तो आई कैन गिव तेलुगु ऑल्सो ओके you have doubt in Hindi language problem you can ask in Hindi also no problem language no problem you ask doubt in Telugu also English also Hindi also I'm okay so tomorrow this we are having and Monday regular class is there from 4 p.m. to 5:15 p.m. 4 p.m. to 5:15 you are having regular every day it is the regular class. Regular session is daily 4 to 5:15 p.m. Okay, so you can attend live just for total networks course complete करना चाहिए तो you can attend the live you learn all the techniques from me and Monday 10 p.m. every Monday I am coming with problem sessions. Problem session every Monday I am coming with some 10 to 12 questions at 10 p.m. every night. This Monday we are doing networks only. So this is the upcoming plan and we have again after this class also you can continue our marathon session 6 p.m. again we are having continuous. Yesterday I have given you the full schedule of the marathon session. You can go through that if you want. So right guys now again I am saying so please go through the special classes of Unacademy. Special classes are completely free for you. You have best possible problem sessions. Everything are there in the special classes. Then you will feel the difference between your YouTube classes and Unacademy classes. In Unacademy, we have the best interactive classes. Even some students are who have taken offline earlier. Now, after taking coaching in the online platform with Unacademy Plus, they said we are very happy, sir. We are able to talk to the faculty directly. I mean, in the doubt clearing every day live doubt clearing is there, sir. We are more interactive in the online classes than offline classes. So if you want to go for the preparation, don't delay the things, guys. Don't delay the things. You compulsory. Okay, if you have a idea of coaching, no thought of second thought. Only Unacademy. Only Unacademy. Only Unacademy, guys. Why only Unacademy, sir? I suggest you one thing is you just ask any single student who is attending my classes or our classes, our total Kreatryx or Unacademy classes. They will give you 100% best feedback. You don't believe in me, don't believe in you will believe me. I know it because you all like me and you all love me. I know that. But generally, I'm saying even you don't believe in any single whoever teaching this, just ask the student feedback. Student feedback is the best feedback. Even he has attended all multiple coachings earlier or no coaching earlier, basic student, any kind of student will satisfy from our classes. We are giving you the best possibility with Unacademy in the free classes or paid classes also. If you have a plan of coaching, you are in the third year or second year, next year I will take, sir, this year I will prepare normally, don't do that. Don't waste a single minute of time. If you want to take the preparation, if you want to take the subscription, don't delay it. Go for 2 years if you are second year or third year student and utilize it now itself. It will give you extra edge. It will save your time. All test series, everything is included in this package. You can attend any single class, one subject. You have multiple faculty also. This is my code for your extra discount. You can get the 10% extra discount. You just remember this code. Just remember this code. If you like our teaching, if you want to enter into an academy, by liking our teaching, you can use this code. You will get extra 10% discount and you will get best possible guidance from me and my team also. Okay, Kanishta Digital for Unacademy students I have completed. For Unacademy students, September I am taking it in Hindi. For Kreatryx channel, that is for YouTube, I am not sure because already Ankit sir videos are there. Thank you, Ram Lakshmi. Right? Very good. So, shall we end the class, guys? So, if you are any Telugu students are there, I hope you are there. Definitely. So, this is the code for you. This is the 10% discount code for you. You can apply this also. Okay. Listen here. So you can select your EMI possibility is also there. If you have a credit card or SDFC debit card or Bajaj EMI, you can apply the EMI option. So these are our channels. Again, I am saying please do like and subscribe our channels. Thank you guys. Thank you for today. Thank you. So continue your learning. We will be meeting tomorrow at 6 p.m. I hope you enjoyed the session. Bye bye guys.